Welcome to my lab class. This is a program we are going to do the YAP program, and this is 1B. This is under SS and OS based program, and we are going to recognize the valid identifier operators and keywords in the given text. So this we'll see the introduction to YAC. This is one of the tool for imposing structure on the input to a computer program, and the input specification is a collection of grammar rules and the rules which is followed by the regular expression, and each rule describe an allowable structure and give it some name. And in this YAC we are going to save our file called dot by using the extension called .y, and this prepares a specification of the input process, and it just generates a function to control the input process. And this function we can say it is a parser, and lex we can say it is an analyzer. And the name is an acronym for yet another compiler, and YAC generates the code for the parser in C programming language. And this is a general tool, and this was developed at AT&T for the Unix OS, and it has also been rewritten for other languages including Java, Ada and all. The function parser calls a lexical analyzer to pick up the token from the input stream. So these tokens are organized according to the input structure rules. This is followed by the regular expression, and in this regular expression a to z, small a to z, and there is a numbers will be there. And so we can by using the increment or decrement things in the count, if you are using the count part, so this should be followed by the regular expression. So the input structure rule is called a grammar. When one of the rule is recognized, then user code supplied for this rule is invoked, and actions have the ability to return values and makes use of values of other actions. So now we will see the compiled, how we can get the compiled output through the YAC. So this is included in the lex program, and it is automatically generated by the analyzer. And by using extension .y for YAC and .l for lex, and we are going to parse it. We are going to lex it, and then we are going to parse it through the CC compiler, and the source program is going to execute, and we'll be getting the compiled output. So this is the steps in writing the YAP program. First of all, we have to use the gedit editor, create a file with extension y. Like for example, we can say gedit filename.y, and we are using YAC d hyphen d and filename.y. And for compiling the thing, we are using the fourth step ccy.tab.c lex.yy.c hyphen ll. So to run the program ./a.out. So when we are going to run the YAC program, it generates a parser in file y.tab.c and also creates an include file. To obtain the tokens, YAC calls yylex. This is the function which is going to return type of int and returns a token, and values associated with the tokens are written by lex in a variable yyl_val. So this yyl_val is a variable which is going to return by lex. In this values can be appended with the tokens. So now we'll see the structure of YAC source program. We have three sections in this YAC specification part. One is declaration section and rules section and program section. So the sections are separated by double percentage and generally used in YAC specification as an escape character. So this is the general format for YAC file, and this is very similar to that of the lex file. We have the definition section, rule section and user subroutines, or we can say it as a C code. So each variable should be separated by the delimiter. Delimiter is nothing but it's a percentage and percentage, and it's just up to the mark to the beginning of the rule section. So definition section we'll see now. Percentage union. It defines a stack type for the parser, and it is a union of various data, structures and objects. And tokens. So these are the terminals written by yylex function to the YAC. And a token can also have type. It is good type for checking and syntax direct translation, and this is a type of token. This can be specified as percentage of token and stack member of token name. So we have an example called percentage token and name number. So this is a rule section. The rule section simply consists of list of grammar rules, and it has a form called body, and it represents a non-terminal name, the colon and semicolon. And these are the YAC punctuation, and by this represents the names and literals. So the names used in the body rule may represent tokens or non-terminal symbols, and the literal consists of a character enclosed in the single quotes. So names, it represents the tokens, and this must be declared as follows in the declaration section. Here we can see the structure, we will see the code part. So in YAP program we have a this YAP program should be appended in the lex program too, so that we are saving the file as separately, like file name dot l for lex and file name dot y for YAP. So in lex file, we are using the percentage. It should be starting with the definition section, and there is a percentage over here and open brace, and we have an header files called hash include stdio.h, and by using y.tab, so we can append our YAP program to the lex file. So we are using extend y/l value. So this is a variable, and we are going to close it. Now we will see the rule section. So here we are using the operators, different kind of operators: plus, minus, star, slash, equals to, less than, and greater than. So this should be followed by the rule section. So now we'll see the YAC file as the same as like definition section, rule section, and code section. Here it should be starting with a delimiter, I mean percentage, and open brace, a hash include stdio.h and standard library.h, and we are giving the variables to the data type integer, that is id equals to 0, digital dig is equals to 0, key equals to 0, and op equals to 0. And so this is the file, this is the definition section, and now this is the rule section, we can say. So this should be followed by open brace and close brace, and this digital plus, this is the increment one, this is followed by the rule section. And now we'll say this is the C code, otherwise we can say it is a subroutine code. So extend int y by lex and extend int y by parse. So this is for the lex file and this is for the YAC file. So now I am going to open the sample input file. I am going to return it. I am going to save my file in YY input, and I am using the do while loop over here to see the thing. So this is the output which I am getting for this. So I am using this gedit lab.kel, and this is for lex and this is for YAC. I am going to run by using YAP d and then the file name .py. So after compiling, we'll get the output like this.